So the sun is important for all of life here on Earth. It's what provides the energy and makes Earth capable of supporting life. The sun is made of mostly hydrogen and helium, but it's superheated to really high temperatures, and so these atoms actually come apart into their components called ions and electrons. And threading through all of this is a really strong magnetic field, and so all of these work together to create all kinds of interesting phenomena on the sun. So the reason we can't see the sun at night is because the Earth actually rotates as it's orbiting the sun. And so when the Earth rotates to put us on the backside away from the sun, then the sun is actually behind Earth and we're in its shadow, and so we can't see it. The sun is huge compared to the Earth. It's actually 99% of all of the matter that's in our solar system. So it's more than 100 times diameter of what the Earth is, and you could fit over 1 million Earths into the sun. Parker Solar Probe is NASA's first mission to touch the sun. It's a spacecraft that's actually diving straight into the atmosphere to study the solar wind and the solar corona. Parker Solar Probe was launched from Earth and put into orbit around the sun. And it has engines on it that make sure that it stays in this orbit that is stable. And it actually does flybys of Venus. And so every time it flies by Venus, then we're able to get a little bit closer to the sun. So Parker Solar Probe has an antenna on it that sends radio signals back here to us at Earth. And so every time Earth and the spacecraft are on the same side of the sun, we're able to use our antennas here on Earth to communicate with the spacecraft and get the data down. So it's really hard to send something to the sun. The atmosphere of the sun is so hot that it could burn up a lot of things. Parker Solar Probe has a heat shield on it that's protecting it. And so maybe one day, if we can take that heat shield and put it on a human spacecraft, we'll be able to go, but not anytime soon. Parker Solar Probe's not ever going to come back to Earth. At the end of its mission, it's going to run out of fuel, and then it won't be able to keep the heat shield pointed at the sun anymore. And when that happens, then the heat from the sun will actually burn up the spacecraft and it'll break into pieces, and these pieces will keep orbiting the sun in the same way. One of the mysteries that we're hoping to solve with Parker Solar Probe is why the atmosphere of the sun is so much hotter than the surface. The surface of the sun is 6,000 degrees Fahrenheit, but the atmosphere of the sun, or the corona, is over 2 million degrees Fahrenheit. That's really weird. That's like walking away from a campfire and getting hotter instead of colder. We don't know why this is, and we're hoping Parker Solar Probe will find out. My favorite part about studying the sun is getting to work on really cool missions like Parker Solar Probe. These are once-in-a-lifetime opportunities of actually measuring what's happening up close and personal with the star. The stars in the sky are actually a lot like our sun. Our sun is a star. But these stars can all have different properties. They could be bigger, they can be smaller, they can be more dense, they can be less dense, they can be hotter, they can be cooler. So our sun is actually pretty average though. It's right in the middle. It's not too big, not too small, not too hot, not too cold. So we're hoping that by studying the sun, we'll be able to figure out more about other stars as well.